Okay, so the next thing we're going to look at now is we're going to look at some properties of quadratic functions. Now, I'm pretty sure you have been exposed to some of this stuff before, right? The only difference that we're going to be taking now is instead of looking at it as y is equal to the quadratic equation, we're going to basically look at it as a function, okay? Now, for the most part, we can go back and review some of this, but I think this should be fresh in your minds. For the most part, when we're looking at a quadratic function, we can look at it in three different forms. We have ax squared plus bx plus c, which is called standard form. You can notice that I'm just replacing y as f of x because we understand that y is a function of x, and we know that quadratics are functions, in fact. The other format that we'll also take a look at is f of x is equal to a x minus h squared plus k. This is usually the most common form that you may have been exposed to quadratics as. This is called the vertex form. We'll also be looking at it in the x-intercept form, also known as factored form, which looks like that. And r and s are intercepts. They're the x-intercepts. So this is called factored form. Another way you can name this is it's called the intercept form. Okay, so this is also called the intercept form. And the reason it's called the intercept form is because it tells you immediately what the x-intercepts are. The vertex form is really relevant because it tells us what the vertex of the quadratic is, which is h and k. And the standard form it's more of a universal format. You can use this to help you to find y-intercepts. You can also find the vertex through this, and we'll explain how you can kind of go about doing that, okay? So a few things that I'm just going to write for each form, just so you can understand some of these properties. And we'll start with the standard form. In all of these cases, this a value here is called a concavity factor. So what a concavity factor is, if a is greater than 0, the parabola, which is the graph of the quadratic function, is going to be concave up. If a is less than 0, the parabola, which is the graph of the quadratic function, is concave down. Okay, so this is something that you want to understand, right? So this is concave up. This is concave down. Okay, and this is true for all of these different forms of the quadratic function, right? So it's important to understand the concavity of it. And when a parabola or a quadratic function is concave up, this point here is the lowest point, and this is called the vertex. So the vertex can be either a minimum point or a maximum point. Now it depends on how the quadratic is opening. If it's opening upwards, it's going to be a minimum point. If it's opening downwards, it's going to be a maximum point, right? So this is the vertex here. This is a maximum point. Okay, so that's something that you want to understand. Right, so a maximum only occurs when the concavity factor is less than 0. Minimum vertex only occurs when the concavity factor is greater than 0. Okay. Now, for each of these formats, you can find some of this information in different ways. So one of the main things is you got to be able to find the vertex for each of them, right? For the x and y-intercept, it'll still stay consistent, right? So if you wanted to find the x-intercept, you let y, or f of x, equals 0, right? Because the x-intercept is where the graph hits the x-axis, right? This is basically where y is 0, okay? So you let f of x equal 0. We're solving for the y-intercept. You just let x equal 0. So in your equation, you're just plugging in f of 0 to find your your y-intercept, okay? So hopefully you guys have an idea what y and x-intercepts are, right?